All right, class, we're going to take a look at section 9.3, which is perimeter and area. And here we're going to start talking about the definition of perimeter. For a polygon, this is the sum of the length of the sides of the polygon. The area is the measure of the amount of surface the polygon covers. And so what you see very nicely in this diagram here is that we've got a amount of, for some reason that's clicking, sorry. This is the distance around this perimeter, and that is just taking the sides, the 4, the 6, and adding them together. And then remembering that there's another 6 feet up here and another 4 feet over here. And so we would add up all the sides and get 6 plus 4 plus 6 plus 4, and so we get 20 feet around the shape. So if I was to walk this, it would take 20 feet to get around this particular shape. The inside is broken up into chunks. Now notice how this looks. There are 4 chunks on the side because there's 4 feet, and here there's 6 feet, 1, 2, 3, 4, 5, 6, and if I count up how many boxes are in there, I would get the same results as if I had multiplied 4 times 6 to get 24. And so I could actually count that there's 24 boxes inside there, and that's where we come up with square feet. And they're square feet because, first of all, it's square, and it's a foot by a foot. So this is 1 foot here by 1 foot here, and so we call it a square foot. All right. So let's take a look at working with other shapes and how they deal with area. So perimeter and area of a rectangle. If a rectangle has length L and a width W, the perimeter of the rectangle is 2 lengths times plus 2 widths. And that's actually what I was showing right here, is that we've got, here's my length and here's my width. It actually doesn't matter which one you call which. And the formula says if I have 2 of the lengths, which was the 6 feet, and 2 of the widths, which was the 4 feet, I would add it together. So 2 times 6 plus 2 times 4 adds up to be the 20 that I got. So 2 times 6 is 12, 2 times 4 is 8, and that gives me my perimeter of 20. And the area is length times width that we showed on the last slide, is that if I multiply the 4 boxes here by the 6 boxes here, I get my total area of 24 square feet. Okay, so what we're going to learn is that we can take we can take our basic shape of a rectangle and build formulas for other shapes like a trapezoid. Now, this right now this shape is not here because what's going to happen is we're going to take this guy and we're going to cut it off and slide it over there for our new formula. So we're going to derive area formulas here on all sorts of other shapes, starting here with the trapezoid. And what you can see is that we could take this trapezoid, this piece that was right here, and cut it and slide it over there. And what we'll notice is that it makes a nice rectangle if I do that. So again, here's my original trapezoid. This part is supposed to be white. Thought I made it to be white. But anyway, this is going to cut off and slide over there so that we can actually see that we have a nice rectangle left over. So if I cut this part out, that's not there anymore. And I'm over here, where now we're looking at a rectangle. So what that does is it allows us to find the area of a trapezoid by looking at it as a rectangle. All I need to know is the original base length, which is this one, and then multiply it by the original height. And so what we've got is that area of a parallelogram, and I said trapezoid, I'm sorry, parallelogram is what that's called. We're going to get the height times the base will give me area. And what we're going to see a lot is that this word base is going to keep showing up. So rather than length and width, we're actually going to call it base. Anyway, so now we've got area of a triangle. So if I've got my area of a parallelogram, what I can do is I can cut this in half, and it'll show that I've got 2 triangles. So again, here's my original parallelogram, and I'm just going to draw a line across there, and what I'm left over with is this nice triangle, and that tells me that the area of a triangle is half of the last slide, which was base times height. So if I have base times height, gives me this rectangle. If I cut that in half to get the area of this triangle, I basically just need to cut this in half, or divide it by 2. So I like to actually say it's base times height divided by 2, or you can say 1/2 base times height. Either way works just fine. I can just go to the next slide, sorry. So there is a formula because sometimes you don't actually know your base and your height, there's a formula here called Heron's formula. And this is something you want to write down and pause, take a picture of or whatever. And so what happens is this is when I know a triangle's sides. So for instance, maybe I know this is 4, 3, and 5. What we can do is we can find the area of this triangle by adding up the side lengths, which would be 3 plus 4 plus 5 here, 3 plus 4 plus 5, and then adding that up and dividing it by 2 or cutting it in half, and that'll give us this letter S. And so then 3 plus 4 is 7, plus 5 gives me 12, and then I divide that by 2 and I get 6. So here my S is 6, so everywhere we have an S, we would put a 6. So we would get 6 times S minus A. So basically I'm just calling one of these A, B, and C is all that this is doing. And here we have 6 times 6 minus 3 times 6 minus 4 times 6 minus 5. And if I square root that, that will tell me what the area inside this triangle is. So if I type that right into my calculator, well, first of all, I could probably reduce it to be 6 times 6 minus 3 is 3, times 6 minus 4 is 2, times 6 minus 5 is 1. And then if I multiply that together, 6 times 3 is 18, times 2, 36, square root of 36. The area inside of this triangle is 6. So it's a nice formula that works when I don't know the base and the height. Now on another triangle, if I know the base is actually like 10 and the height is 7, then I can just multiply 7 times 10 and then divide that by 2. So it's just 70 divided by 2, and that give me 35. Oops, sorry. And so my area here, if that was my actual height and this was my base, would be 35 units squared, whatever the units are, by the way, units squared. So feet squared, meters squared, whatever we've got. So here we've got a shape where we've got a recreation area in the shape of a parallelogram. A pound of grass seed covers 100 square yards. It's just background information that we know. It says how much grass seed is needed to seed the entire area. So ignore the fact that there's shading yet, because what we want to do is we want to fill this entire thing with grass seed. So I need to know how much grass seed I need to buy. And that's where area comes into play, because they actually show on the backside of grass seed how much area it will cover. So to do that, we go back to our other formula that shows all I have to do is find my base and times it by my height, which is 150. So if I do that, I get 200 times 150. So that'll give me 30,000 square feet that I need to cover with grass seed. Well, 1 pound covers 100 square yards, and this is 30,000 square yards. So this is yards squared. We divide that by our 100 to show me how many pounds I need, and that'll cancel out 2 of the zeros. So I would need 300 pounds of grass seed to cover the total recreation area. So now we have, so that's the answer for A, is the 300. Now, question B then says, suppose we want to seed only the triangular area right here, this guy right here, ACD. How much grass seed would be needed then? Well, what we can do, there's a couple ways you can approach it, but that's what I was looking for. What we can do is just take our area of the triangle and give me, I've got a base of 70 and a height of 150, and so if I just find this area, that'll help me find out how much grass seed I'll need. So I take and use my formula that says you take your base and times it by your height and divide that by 2. So we've just got 70 times 150 and then divide that by 2. If we type that into our calculator, 70 times 150 is 10,500, and divide that by 2, we get 5,250. So 5,250 is how many yards squared we have. It's supposed to be d squared, and what we need to do then is just take the yards squared, or square yards, and divide it by 100. And so if I divide by 100 here, that'll show that I need 52.5 pounds of grass seed. Okay. And now we've got area of trapezoid we can take a look at by understanding that we've got basically a there's a rectangle kind of inside this. Here we've got an actual formula, but what I want you to recognize is that if I cut this off over here, the way that this is set up now, I can flip it over and put it over here, and it'll look like that. And if I do that, you'll see a rectangle in there. And so what we can do is figure out what the actual base of this rectangle would be by averaging the bottom and the top lengths. So that's what's happening in this formula right here. You've actually got the first base and the second base. You're adding them up, and then you're dividing by 2 or multiplying by half. If you do that, that averages the two bases, and it gives you one base, and then we already knew the height originally. Going back, see the height was right here. We just rewrote it over there. And you'll see that if I average the bases, in other words, add them and divide by 2, and then multiply the height, you're really just doing area of a rectangle. So let's take a look at that here. So basically, I want to cut this off and make this shape go like that. Well, I don't know exactly what this distance is, and I can't just say, well, I subtracted. You know, I don't have any idea what I subtracted. So what we're doing is we're saying, all right, the distance from here to here is the average of 8 and 4. So if we just take 8 and 4, add them, and then divide by 2, 8 plus 4 is 12. 12 divided by 2 is 6. This base would have a length of 6 from there to there, and it'd also be 6 on the top. We already know that the height is 3, so if I want the area of this trapezoid, it's 8 times 3, and that gives me 24. That is the area, square feet, so feet squared, that my trapezoid covers. So then another concept we need to talk about is Pythagorean Theorem. If we have this wonderful formula, a squared plus b squared equals c squared, it'll allow us to find missing parts of triangles. Now the key here is to understand the legs here are in blue. What they do is they touch the right angle. So if you see your little 90-degree corner, the things that are touching that are called the legs. The hypotenuse is always the longest side, and what I've had people tell me before is that if you just connect the dots in the square and point an arrow, it will always point at the hypotenuse. Sometimes it's hard, depending on the picture, to see which one's actually the longest side, but the hypotenuse is also defined as being the longest side. So if we have these two shapes here and we're to find the missing part, on this case, this is the most basic, straightforward case where you've got the two legs and you're looking for C. All you do is you set it up with your formula, a squared plus b squared equals c squared, and your a is 6, or your a is 8. It actually doesn't matter which leg is which, but 8 squared plus 6 squared equals c squared, and then you go ahead and square them, and you get 64 plus 36 equals c squared. And then your job is to add these together to get 100, and 100 equals c squared. And then you simplify by square rooting both sides, and the square root of c squared is c. I still got red for a different color. Here we go. Square root of c squared is c, and the square root of 100 is 10. So 10 equals c. That means this third side is c. It's 10, sorry. Now over here, this is your a little bit harder case where you've got b missing. And so when you have a leg, you have to do a little bit more work. And that is, here we have 15 squared for c, or for a, I'm sorry, squared, plus b squared I'm missing, so we write b squared, equals c squared is my 16 squared. So our job is to find b by subtracting the 15 squared to the other side. So we've got to make sure that we've got our actual subtraction happening, otherwise we will make a mistake here. So 15 squared from both sides. And what we have is b squared equals 16 squared minus 15 squared. So let me go ahead and type that into our calculator. We have 16 squared minus 15 squared gives us 31. So b squared equals 31. And then your job is to finish by square rooting, and we get square root of b squared, square root of 31, b, because whenever you square root, by the way, I don't know if I mentioned it before, but square roots cancel out squares, and so b is equal to the square root of 31. 31 doesn't have an actual nice square root, so when we do square root 31, we're going to get a decimal approximation of about 5.57. 5.57 would be about what it is. Okay? Now here's a nice application problem. We've got height of a pyramid. So this is taking the Pythagorean Theorem and applying it to a three-dimensional object. What our job is to do is to find the actual height here. Well, to find the height, I need to know this this distance here. We'll call it x, and all we know is this hypotenuse, and then we know this side length here. So we've actually got a larger issue going on. We need to take a look at the fact that this shape is taking a look at the bottom. See the 230 right here? Our job is to find x, which is redrawn over here. So what this shape does is it's taking a bird's eye view down on top of the pyramid, so that we can actually figure out, well, what's this distance? Because I need to know this distance before I can find the height. Because right now what I've got going on for the height is here's my height, here's my x, and then I know that this is 219. Well, before I can find the height, I got to know x. And so what I need to do is, with my bird's eye view of the base of this, I need to set up that this is 115, which is half of my 230 overall. So half of that gives me my 115. And if this is 115, this makes a 45-45-90, which means that these are isosceles, or this is an isosceles triangle. So that this is also 115 out. And we also know that here because this here would be a distance of 115 also. And this would be 115 because it's a square. So we know that this distance out to the middle is also 115. So knowing that information, what I can do is the Pythagorean Theorem to figure out x. And so if I figure that out, I set up 115 squared plus 115 squared is equal to x squared. And so then I go ahead and take that on my calculator, 115 squared, and then times it by 2, because I have 2 of them, and then I get 26,450, and that equals x squared. So if I just square root that, I get 162.63. So x is 162.63. So that's helpful over here now. 162.63 goes there, and so then it also goes here on my triangle. So erase that. And so I got my 162.63. So now my job is to find height. So what I've got is a new triangle, so I get to do Pythagorean Theorem again. So I get to say 219 squared is equal to, because this is my c squared, is equal to my height squared, which I don't know, plus 162.63 squared. So if I get h squared alone, I would subtract the 162 to the other side. So minus 162.63 squared. Then I go ahead and do that on my calculator. So 219 squared minus 162.63 squared. And that gives me 21,512. So I don't really have room right where I'm at. I can make room, get rid of this circle. And so I've got h squared is equal to 21,512. And then if I square root that, I get my actual height, which is now 100. So h equals the square root of this. I square root that. That gives me my actual height of 146.67 meters. Okay, so it's a very multi-step problem that includes 2 parts of solving with the Pythagorean Theorem. And now we're going to wrap this section up with a quick little discussion on circles. And circles have 2 special parts. They've got circumference, which apparently got a dash. It looks like it got cut off there. Circumference is 2 pi r, and area equals pi r squared. Because I have so many students that get these 2 formulas confused, I usually like to say circumference is equal to diameter pi, because 2 radii gives a diameter. In other words, a diameter is equal to 2 radii. radius, 2 of them, gives you your distance across the circle. So anyway, what we've got here is we're going to be asked to find the area of the shaded region on this particular, on a problem just like this one in your assignments. So to do this, what we want to recognize is there's actually a square in the middle, kind of between these two circles. So first thing I want to do is realize that I can find the area of this square if I shaded this whole thing in, and so, all right, well, here the area of the square would be 2 times 2, and that's 4 meters squared. So the area of the square originally is 4 meters squared. Well, what I want to notice from that is that I'm taking out basically half of a circle and then another half of the circle. So really what I want to do is I want to take away the area of the circle. So if I have my 4 meter square and I subtract my circle, I'll have the shaded region. So all I have to do is figure out, well, what is the area of the circle? I should probably put a circle for area, not for a circle, but area of a circle. So to find the area of this circle, I need to know pi r squared. Well, first of all, what's my r? Well, I said here that diameter is equal to 2 r's. This is a diameter, that's the distance across the circle. So diameter goes from here to here, and so I need to cut that in half to make a 1 is my radius. So if 1's my radius, then I say pi times my radius squared is my area of the circle. Okay, so really it's just pi, because anything times 1 is just itself. So really, if I take 4 and subtract pi, that would give me the area of the shaded part. So if I do that on my calculator, 4 minus pi, or 3.14, so where's my pi button on my calculator? There we go. That gives me 0.8, so equals 0.858 is the area left over by the shaded region. Okay, so 0.858. So we've got one more shape here that we're going to do the same thing. And now here, we want to figure out, well, what's this shaded region? Well, to get at the shaded region, we have to actually first know the whole circle, and then what I want to do is do some subtraction. I can cut it in half and get rid of all this white space, and then I need to subtract out this triangle to get the rest of it. So let's work it out. So the whole circle would be 2, which is pi, or sorry, which is not pi, which needs to be squared and multiplied by pi to get the area of the whole circle. So this is the big circle. Okay, the area of the big circle is 2 squared pi, because my radius is 2 feet. If I square that, I get 4 multiplied by pi. That's the area of the big circle. So the whole thing's 4 pi. Now, right away, I need to cut that in half, because I don't want this half. So let's just divide it by 2, and I get my half circle left over. So this part left over, so I know that's a lot of shading, I'll erase it, but that leftover part now is half of what we just started with, which here is 2 pi. So basically, all of this was 2 pi, and all of this is 2 pi, for a total of 4 pi. Okay? Now, from the 2 pi on this half, I need to cut out these triangles. Now, I said triangles, plural, because that's the way we need to look at that. So to get those, I want to recognize that my base for one of the triangles is 2. My height would also be 2. So if I'm just looking at this triangle right here, what I would see is that it would be, so I'm just looking at this triangle right here, you'll see that my base is 2, my height is 2. So if I multiply and get 1/2 base times height, 2 times 2, I would end up with 2 times 2 is 4 divided by 2 is 2 is my area here. And then I just double that, because this one's 2 is my area right there. So I have a total of 4 square feet that those triangles consist. So if I take my 2 pi, which is this whole leftover region, and subtract my 4, that will give me my leftover portion, the leftover shaded region. So 2 pi minus 4 gives me 2.283 feet squared is the leftover little small shaded region here and here together. Okay. Well, good luck in this section. Let me know if you have any questions through the Ask My Instructor feature of the lab.